This video will be reviewing forecasting. What is forecasting? This is the practice of predicting something in the future based on current information we already have. It helps businesses project where we're going to be in the future, where they should put their goods and services, where to determine what future sales are going to be, future input, future output, even inventory, knowing where the problems are. There's two basic methods of forecasting. There's qualitative and quantitative. Qualitative is often used by experts or forecasters in terms of, we've done this before, I know what it's going to be like. Usually you do have an expert, but there's no quantitativeness behind it. Steve Jobs, when he invented the iPod, the first thing he was thinking about is, we're going to sell music to millions. Put it on this tiny little 2-inch by 3-inch piece of metal that's maybe a half an inch thick and would have up to 5,000 songs on it. There was no way to forecast. He knew the future, or what he thought he knew the future, and he was correct. However, you also look at all these people for professional and college football games, basketball games, baseball games. They're experts because maybe they played, or they were former coaches, or they've been watching the games for years as announcers. And they're going to use their past experience knowing this information to make a forecast. But it's qualitative. There's no hard numbers to put. Quantitative method uses a mathematical process, and this uses other information we have to determine with a certain amount of certainty what will be the outcome. Now, forecast about three things. Future events, it's based on past events, and there are several forecasting techniques. Now, regardless of what forecast technique, and I've got these listed here, you develop a base forecasting based on where a company or organization or group or current product is in the market, and it's to estimate where we're going to be in the future. Also, things are going to happen. Like I was in the medical industry, new laws, new FDA or Department of Health and Human Services regulations will also affect things. Think about, for example, with COVID, you could predict how many people are going to be employed, how many people are working at home until COVID came about, and that changed everything. So that's how we regulate the forecast. We need to review regularly how accurate is our forecast to the actual, and then modify it. There's two sources to get information for forecasting. Primary sources. That's where you collect the data on your own. It could be from surveys. It could be from responses to mail. It could be from phone calls you made. It could be from all your other sale information you've gotten. All right, it's very limited because it's only for you. There's secondary sources where you can look at markets, look at products. The U.S. Census Bureau has a lot of data on population. There's also all kinds of organizations that have the information. There's two companies called IRI and Nielsen. They record every scanned product in the United States, and you can see during what your product, anything that's scanned by cash register, you can record where that was sold. And you can buy that information. Now, we did some forecasting last week about regression. This is basically the algebraic formula. If we can determine if we have X's and Y's with causes and results in terms of data, two different variables, and see how one affects the other, we can predict where something's going to be. Regression is utilized for predictive analytics. If we know what the past was, we can predict with a certain algebraic certainty what the future will be. It also lets us optimize the business process. If we know our sales have gone up every month by 1% over the last 14 months, and we can calculate it's 1%, then we should plan on all the inventory, the increase in sales, the increase in profit also being 1%. If call centers are down 15% every month, well, then we say we don't need as many people. We need to reduce that. But this is what it is. It also looks at seasonality. There's more sales during certain seasons for one thing than there is for another. Such as more sandals are sold in spring and summer months than fall and winter months. So companies stores such as Walmart or Kohl's will probably put less sandals out there in winter months than they will summer months. Yeah, I know there are deals overall, at off time months, but this is how we become efficient. We want to sell as much as possible during the best time. And this also allows us to support decisions. If we have a rationale why we're forecasting this, why our sales are going down, or why our input is going up, or why our medical response rates are being consistent, we have quantitative math to back it up. It also allows we can correct what we're doing here and provides new insights as we look at this. Now I'm looking at from our data from last week, and this is a regression line. This is the old faithful eruption times between how long it erupts and times between eruptions. And we've actually got an equation here. The time between eruptions can be predicted by 12.481x, whatever time we put in there, 1 minute, 2 minutes, 3 minutes, 4 minutes, 4.5 minutes, plus 33.683. This allows us to know how determine if it goes on for 2 minutes exactly. We can put in 2 for the x and then predict what the time will be between eruptions. Now, what I actually have here is the population in the United States from 1961 to 2021 of actually people who are age 65 plus. And you can see 1961, my first X, I had 9,129,501 people age 65 plus. It's grown to 2021 at the very bottom here, 30,224,520. And I've graphed the actual here, and then I've graphed the regression. The blue solid, where it kind of dips and goes down, is the actual. The red is my regression line. That dotted part, past the regression line, is forecasting what it would be past 2021. And as you can see, overall, it's fairly accurate. And that's a good thing. We can say with certainty throughout here, it is pretty consistent. But one of the problems is it's a straight line. It doesn't take account of certain things. In fact, if you look at the actual right here from the last probably 17 years, it's greater than where it's forecasted with this dotted line here. In fact, it's greater now than it's even forecasted through 2031. And there's things you'll count. You look at it, where did this bump go down and suddenly go up? That looks like it's about 2001, 2002. Well, I'll tell you some things. There's more people living longer because we had better cancer drugs. We actually had cancer drugs that could destroy cancer. We actually had better anti-infectives, better surgeries, and there was a lot of medical breakthroughs in the late 2000s. I mean, the late 1990s and the early 2000s. Another thing is the number one drug in the world, Lipitor, which reduces cholesterol. Well, one of the highest rates of death is caused by heart attacks, and that is often caused by pieces of plaque breaking up and causing a heart attack or a stroke in your arteries. Well, reduce the plaque with Lipitor. Well, Lipitor came around in about 1997, and this was started going up. So now people are living longer and had fewer heart attacks because of this. So the problem with regression, it takes into account everything from the very beginning here to the last data. It takes in every one of those. And the problem is it gives equal weight to this one, every one of them. And that's why we have a forecast as below where the actual already is. Now we got the moving average called ARIMA, or Auto-Regressive Integrated Moving Average. And this is basically saying I'm going to take the average of the last 3 or last 4 or last 5, whatever, divide that and see what it is. Let's say I have 3 sales periods, 100, 3 months ago, and 100, 122 months ago, and 230 last month. I'm going to divide by 3. 100 plus 120 plus 230 equals, what do we get here? That'd be 220, 420, 450. 450 divided by 3 is 150. So our forecast for the current month, based on the previous 3 months, of the 100, 120, and 230 is 150. Now let's say the next sales period is actually 40. So we'd go 120 plus 230 plus 40. 120 plus 230 is 350 plus 4 is 390. 390 divided by 3 is 130. So we'd forecast 130. The good thing about moving average forecasting, it allows to take into account the more current information, as opposed to regression, it takes in all the information. Now, the disadvantage is it's very short term. If you're a new company and you want to forecast your first 6 months, you only have 4 months of data, yeah, use your 4 months of data. And sometimes you don't have, or if you're launching a new product or a new service, or you got new information on some kind of medicine or some kind of illness, yeah, you may have only short-term information. This is what you do with this. But it doesn't respond to sudden changes, as you can see right here. Let's suppose we had we had a previous sales 230. Well, that's great. That sounds really good. Was that Christmas time? Was that a seasonal thing? And then the following month is 40, which would be January, when sales are slow. This could be October, November, December, and this could be January, right here. And the problem is, this is not consistent for long term. It's predicting things short term, which is good, but long term, it's kind of hard to say with a high amount of accuracy that we can project this for an extended period of time. Now, what I've got here is I've got not only the regression line still in the red, I've got the moving average. And you see the moving average hugs the actual. The moving average is that dotted blue line. I'm sorry, yeah, the dotted blue line. The solid blue line is the actual. And as you can see, the problem is when I start going beyond that, I can only predict for the 3 previous times. And it gets very flat. We know that's not the case. This appears to be moving up. I find it hard to believe it would stay consistently flat. Good for short term because it hugs it. Long term, over many months or many years, I'm not comfortable with it. Then there's trend adjusted exponential smoothing. Now, I'm not going to make you learn the formula here, but this is the formula to find it. We have 2 sets of formulas here. And that's based on this. Is the forecast f of t plus 1 times current plus 1, so be the future time period, equals a, which is the actual period, and then the time trend. And these formulas are based on these 2 formulas themselves. And we plug it in. What I want you to understand here is there are 2 things called smoothing curves. This alpha and this beta. This alpha and beta, we manipulate around to try to see what is the most ideal fit. Now, I've done this formula in Excel. I'm not expecting to do it. I want you to recognize it, though. Here is a short one for 18 months. Now, I want you to notice here, the blue is the actual data, right through here. The brown is the trend adjusted exponential smoothing. Now, what's interesting is with those formulas and the smoothing averages of the alpha and the beta, it actually learns from the prior information. Each data takes into account not only the next number, but how off it was from the previous number to the forecast. And as you can see, the space between these 2 get narrower and narrower as it learns it. And you can see this here's the blue, the actual. It looks like it's going to head in this direction. And this dotted brown looks like, yep, that's where it's going. But the more important thing is you can see as it learns the data, the forecast from the actual, it gets narrower and narrower, the differences. Let's do the trend adjusted exponential smoothing for my age 65 plus individuals in the United States, projecting 10 years. From 1961 to 2021. I start 1961, and you see there's a large gap here. Not huge, but there is a bit of a gap. And it gets narrow and narrow, and after a while, it learns from its mistake, or I say its difference, and look, it hugs it right there. In fact, it's projecting right where that blue line is forecasted to go over the next 10 years. That's where it looks like it's going to be. So the important thing is this is really a form of Bayesian analysis. Bayesian analysis basically states, and I'm not going to go through it today. You're not required to know it. But Bayesian analysis by Reverend Bayes, who was a mathematician in the 1800s, and what he found is he said the more current information has a greater effect on the future than past information. With regression, all the information, whether it's 30 or 40 or 50 years, has the same effect as 2 or 3 years. Transition exponential smoothing Bayesian analysis basically says the more current stuff has a stronger effect than the more distant stuff. The more distant stuff gets dampened out. The more current stuff has a greater effect on where the future is. And it's like I said, right around here we started having better cancer drugs, better cholesterol drugs, and that increased how long people were living. And that has a greater effect on the medications we had 50 years ago. In fact, 50 years ago, we didn't even teach CPR. Well, now we teach it in high school. So, and that's just an example. We didn't have, I think the first heart transplant was 1961. Before that, we didn't have it. There were very few, if any, cancer treatments. There was radiation, but there was no chemotherapy back then. So people are living longer, and this happened more currently with these better medications and better treatments than what happened 60, 70 years ago. If I look at all three forecasts, you can see the trend deduction of exponential smoothing appears to be the most consistent. Moving average just flattens out. And the regression kind of follows an upward trend, but like I said, it's taking into account, and it's being dragged down by the previous data from a long time ago, because it gives same weight from a long time ago as it does the more current data. The transaction exponential smoothing takes the more current data with a greater weight. And the moving average only takes the most recent information, short term.